There are a lot of topics we need to discuss in this video. We'll start with this big topic called SOCs, S-O-C-S, and that's just a way to help us remember the ways that we're going to describe our data. The first S stands for shape. What is the shape of our data? And when we talk about shape, we're going to be looking at today dot plots and stem and leaf plots, or stem plots, and discuss shape. What does it look like? Is it symmetrical? Does it have symmetry? Is it skewed to the left, stretched way out on the left? Is it skewed to the right, stretched way out on the right? And we'll discuss these in just a moment. The O stands for outliers, and outliers would be data points that are way different than most of our data points. They are data points that just seem abnormal. They don't seem like they're anything like the rest, and it's very important in this unit that we discuss outliers. We will not discuss them in this lesson, but we will discuss them in this unit. Very important to identify things that are kind of way off the mark. The C stands for center. What is the center of my data? What's the middle? And there's different ways to find middle. We can find the mean, or just the average. That's kind of a middle. We can find the median, which is actually the middle number when I line them all up. And we can find mode, which is kind of the most common, oftentimes occurring somewhere towards the center. So we have shape, outliers, center, and then we have spread. How spread out is my data? Spread can be measured really by just talking about, hey, what's the smallest and what's the largest values? What are the min and the max that I have in my data? That kind of helps me understand spread. Another number I could calculate is range, and we've discussed that in a previous lesson. We can talk about range to help us understand how spread out or how far apart my data is. So keep in mind SOCs. You'll be asked to talk about SOCs in lessons, questions, and things like that. It's shape, outliers, center, and spread. So let's talk about shape a little bit. There's really kind of four main ideas when we talk about shape. We have shape that is skewed left. Skewed left means that the left side is the side that contains the data that just seems a little bit abnormal, not quite like the rest. So think of it as left stretched out, drawn out on the left. Right? A lot of times when I'm plotting data, things will start to look like this, and maybe they will be a lot higher on the right. Okay, this is kind of an example of a very simple dot plot actually, but um, and maybe this is kind of what I have for my data when I'm done plotting. And a lot of the data kind of draws out on the left. It's kind of stretched out on the left a bit. That is skewed left data. We have skewed right. Skewed right would be where it's kind of really drawn off on the right. It's stretched way out on the right because that's kind of where the data that's not a lot alike the others. The data points that are stretched out on the right here are the things that are just kind of abnormal in this case. It seems like most of the things fall on the left. Skewed right means, hey, there's some stuff on the right that just seems a little bit off. We also have bimodal. Bi, hey, this sounds familiar. Bi means two, and modal is like modes. But bimodal, when we look at bimodal data, it basically what it means is it's saying it has two bumps in it. Two bumps in a sense, and that's this graph here that kind of goes up, it comes back down in the middle, goes back up again, comes back down. It's bimodal is kind of two bumped, if you want to think of it that way. And then we have symmetrical or roughly symmetrical. Data is generally not perfectly symmetrical, but it's kind of the one bump situation. I've got high in the middle and low on the ends. That is shape of data. Those are descriptors: skewed left, skewed right, bimodal, and roughly symmetric. So let's talk about a dot plot. I know I did one real quickly here on this slide, but let's move on. A dot plot basically is exactly what it says it is. It's just me putting dots on paper that represent how many times each thing occurred. So in this little study here that you see on the screen, I just surveyed some students and I asked, how many times a day do you brush your teeth? And these are the responses I got. Right, so when I look at this data, there's a few things I can look at. I could say, hey, what's the average? Well, I'd have to add all these up and divide by how many there are. What's the median? I'd have to find the very middle if I listed all these people out and all the numbers out. We can talk about SOCs like we have so far. We have shape. the shape of this graph. It's not high in the middle and low on the ends. It is a little bit, but it's a little more stretched out on the right side, so this would be called skewed right. We can talk about outliers. Now, outliers are things that are kind of just not like the others in a way. And I'd have to really look at somebody who brushes their teeth 5 times a day. I'd have to ask myself, is that kind of different compared to the norm? But statistically speaking, there's a way for us to answer the question, is that an outlier? Is it really different than the norm, or really different than kind of the normal data point? That we'll study in a future lesson. So we'll just for now say 5, well, maybe it's an outlier, maybe it's too extreme. I don't know, we'll see. We have center of data, which again is mean, median, and mode. And we have range or spread. We could talk about 0 to 5, or we could talk about a range of 5 and things like that. So this is all a dot plot is. How many times did each thing happen? Put a dot down for each time it occurred. As you can see, there's 3 people that told me they brush their teeth 3 times a day. 1 person that just simply doesn't brush their teeth at all, and so on. So that's dot plots. Let's move on to stem and leaf plot. A stem and leaf plot is really basically just another way to list out your data and to show what it looks like. And what I have here is some exam scores from a past exam, and not a whole class. I just grabbed some numbers. And what we're going to do is we're going to create a stem and leaf plot, or what the book calls a stem plot, just to kind of show how to do this. And the way you do it is you first create your stems, and you ask yourself, what are my numbers? And my numbers up here, when I read through these, the smallest number I see is 55. And the largest number I see is 97. So we're talking 50s to 90s. And my stem is generally the first digit in the number, or if it could be 2 digits. It's basically all the digits but the last digit, if that makes sense. So my stems are going to be like, here's 5 that represents the 50s, a 6 that represents the 60s, a 7 for the 70s, an 8 for the 80s, and a 9 for the 90s. So what I'm going to do is I'm going to say, hey, I need all my 50s. Who are all my 50s? It looks like I've got a 55. I'll cross that off. And that's it. So 55. Now the 5 for the 50 is already here. So on the leaf, I'm going to put just simply another 5. So right now I have shown that there is a 55 in my test scores. The next I'm going to go to my 60s. I see I've got 68. And I've got 65. I have 2 60s here, and it's very important, very, very important that you know that you are supposed to list the leaves off, the leaves, in numerical order. So it's 65, and then 68. Okay, and I'll cross those off because I've used those. Moving on to the 70s. The 70s, it looks like I've got a 75, a 72, a 70, and a 71. And now I need to put those in order. So I'm going to go 70, 71, 72, and 75. So it's going to go 70, 71, 72, and 75. And it's also really quite important to keep these lined up nicely. It'll help you understand how spread out your data is and how many of each you have. Moving on to 80s, we'll do the same thing. We have 86, 81, 88, and 81. All right, so let's look at that. We have 2 81s that we do need to list it twice. We want to show that it happens twice. So there's 81, 81. We have 86 and 88. 86 and 88. And we look up to the top. Hopefully we have 90s left. I see a 93 and a 97. So I'm going to go 3 and a 7. And there is my entire stem plot, or stem and leaf plot. It really shows and tells me what my data looks like. And in all honesty, I kind of like to explain that it is possible to take this data and to really kind of turn it to make it appear like a dot plot. If I just take a quick picture of this here, and there's my stem and leaf plot. I just made a copy of it. But it's kind of interesting if you turn your head sideways, or I'll help you. I'll actually just turn the picture sideways. A stem plot is basically just like a dot plot. It's just turned. And not only that, it doesn't use dots, it uses numbers to represent where exactly each dot is in the chart. So if it helps you to visualize a stem and leaf plot as kind of a sideways dot plot, maybe that will help some people understand what to do. Now there's also a thing called a back-to-back stem and leaf plot. So what I've done in this is I've already written out the whole back-to-back stem and leaf, and I'll point out a few things. So what I have is I have two different classes now where I grabbed some test scores and I wanted to compare the two. So a back-to-back stem and leaf plot is actually more useful and more important, I guess, when you're trying to compare data. You want to compare two sets. So I have my first class listed down here. Class 1, I listed all their data. And here's class 2, I listed all their data on the right. And I want to compare. A couple things to note. The number here that's closest to the 5, remember this is 50. This means 52, and this means 59. Remember, the number closest to the 5 should always be the smallest. And for class 2, this is the way we did it on the last slide. But for class 1, you have to remember it's a little bit backwards, because for the 60s, the 65, the 5 is closest to the 6, and then 68. Okay, so it goes from smallest to largest, reading backwards now. Closest is always, smallest number is always towards the center, always towards the middle. The reason we do this is we can really kind of compare now which class did better. Sure, an average might help us, but right now we could look at this and just see, hey, you know what? 70s and above, I kind of have the majority of my class. And when I look at class 2 over here, I only had 3 people with 80 and 90. I can just tell visually by this picture